Hello everyone and welcome to geometry class. Today we're talking about chapter 1, lesson 2, measuring and constructing segments. So first we're going to get started just by doing this warm-up. So on your own, I want you to go ahead and work that out. Here's my friend the pause dragon reminding you to pause your device, work on the 1, 2, 3, 4, 5 problems, and then when you get done, press play and we'll go over them. All right, see you in a bit. See you in a bit. All right, we're back. Let's go ahead and see how you did. So this first one, number 1, we have 7 minus a negative 3. These are just some of the skills you're going to need for today's lesson. So let's just go over them first. Okay, whenever you have a negative and a negative right here, that ends up being a positive. So 7 plus 3 is equal to 10. So if you got that one right, great job. Over here, number 2, negative 1 minus a negative 13. Those two negatives right there become positive, so we end up with negative 1 plus 13. This is a negative, this is a positive. The signs are different, so you take the difference between the numbers, which would be 12. Then you look at 1 and you look at 13. Which number is bigger? 13 is bigger and it's positive, so that means our answer is going to be positive as well. All right, great. This is the absolute value of negative 7 minus 1. So we're going to simplify this inside the absolute value symbol first, then take the absolute value. So negative 7 minus 1, this is a negative, this is a negative. When you have two negatives that have the same sign, what you do is you add the two numbers. 7 and 1 is 8, and then you keep that negative. Okay, so negative 7 minus 1 is negative 8, and then what we're going to do is take the absolute value of negative 8. Whatever's in the inside of an absolute value is always talking about the distance away from 0. And so we know on a number line, 0 is right here, and negative 8 would be down here. So how far is negative 8 away from 0? Well, it's 8 units. So that means that the answer is 8. But kind of the quick way is anything that is inside of an absolute value, it just always becomes positive. But the reason why it's positive is because you're talking about the distance away from 0, and distance is always a positive value. All right, cool. Let's start solving some equations. So what I see, whenever we solve an equation, we want to figure out what x is. Well, here we have x's on this side of the equation and this side of the equation. The equal sign, you remember, separates the two sides of the equation, right? So this is the left side, this is the right side. Okay, so our first thing is obviously we want to figure out what x is, but x is on both sides. So we have to get x on the same side. How we do that is I like to move the smaller of the two. So which smaller, 2x or 9x? 2x. So I'm going to do the inverse operation. Right here, 2x is positive, so I'm going to subtract 2x to both sides. The positive 2x and negative 2x cancel each other out. So what I'm left with on this side is 3x equals, and I like to put a line and just have all my equal signs line up so things are nice and neat. 9x minus 2x is just 7x minus 11, and here we're trying to get x by itself, so we have to get rid of that 11. The inverse operation of subtraction would be addition of 11 to both sides. 3 plus 11 is 14 equals 7x. Still trying to figure out what x is. This is 7 times x, so the inverse operation of multiplication would be division. We're going to divide by 7 to both sides, and we end up with 14 divided by 7, which ends up being 2 equals, 7 divided by 7 is 1. 1 times x is just x. Or I like to just switch it and make it x equals 2. X on the left side is always better. Whenever you switch it like that, that's called the symmetric property of equality. And we're going to be learning all about different types of properties in this class. But you'll need to know that one, but you don't need to know it yet. Okay, let's look at number 5. Now we have 3x equals 4x minus 5. So if we obviously want to figure out what x is, right? And we notice that on this side of the equation, there's two different x's, one on the left, one on the right. Now what I said before is I said, oh, okay, I always like to move the smaller. So here the smaller would be 3x, right? So I'd move it over there. However, since this x is already over here by itself, this is kind of like the one exception. I'm going to move this 4x over here because then it's just going to make my job easier. If I move the 3x over here, then this is going to equal 0. Then I'm going to have to move the 5, and then I'm going to have to move something over. And I end up having to do more steps and more work. So this is actually the easier option, is to move the bigger one over. And so I'm going to do the inverse operation of this positive 4x, which would be negative 4x. So we have 3x minus 4x, which ends up being negative x, equals negative 5. But let me tell you something really quick. So the reason why over here I always move the smaller one is because my answer always ends up being positive, and I just think I just like working with positive values. But when you move the bigger number over to the smaller one, you're always going to get a negative. So then you're just going to have to make sure that you remember all of the right little details when dealing with a negative. So anyways, but for this instance, I like to move this one over here because now the x is over here by itself, and all I have to do is get rid of this negative. So when you see negative x right here, x is not by itself. There's a negative. This is actually a negative 1 times x. That's what that means. And so this is negative 1 times, right? So we'd say, oh, the inverse operation is division. However, all I'm trying to get rid of is this negative. So I actually like to just multiply both sides by a negative 1, because what is a negative times a negative? It's a positive, right? I'm going to do that. A negative times a negative is positive. So I'm going to do it to both sides right here. So negative times a negative is a positive, and I'm left with x by itself, which is exactly what I want. Okay? Then over here I have a negative times a negative, which is a positive. 5 times 1 is 5. And the x is over there on the left side, which is wonderful. So we don't have to do that symmetric property of equality. And we're good. Oh, 6. I didn't even see that one. That's a part of the warm-up too. Let's see what it says. It says, how many numbers are there between 1/2 and 3/4? Well, let's look. I actually have a ruler right here. Let's see here. On my ruler. Okay, let's see. Here is 1/2 an inch, and there is 3/4. How many numbers are in between those two? Well, if you look, there's these little hash marks, right? 1, 2, 3. But in actuality, for between here and here, there can actually, this is just like the standard, like for measuring. I think this goes down to the 16ths. Because I think there's 16 in here between for this inch. So if we count them up, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So this just goes down to 16ths. But it can go down way, way smaller in nitty-gritty increments than that. So really the values between 1/2 and 3/4, actually there are infinite amount of values. So that's the answer. There's infinite amount of values between 1/2 and 3/4. They're just an infinite amount of really, really, really small numbers, but there's still an infinite amount of values. Okay, cool. This is the first postulate of this section, and it is called the Ruler Postulate, okay? So what this says, the Ruler Postulate says the points on a line can be put into a 1-to-1 correspondence with the real numbers. Okay. I remember the first time I read this postulate, and then I was like, what does that mean? The points on a line, okay, so here, I'm going to use my little ruler that I just broke out, if I could pick it up. Can we see this? Can you see it? Okay, so here's our ruler, right? The points on a line. So you're talking about the points being on a ruler. So like if there was a point here, can you see that that is a 2? Can you see? Is it out of focus? Yeah, there's a 2 there. There's a 3 there. There's a 4 there. So basically that's just saying if there's a point there on 2, the point is 1, the value of 2 is 1. So that's what this 1-to-1 correspondence is. This one is talking about the point. This is talking about the value. So all it's saying is whenever you're using a ruler and you put a point on that ruler, that point has a value. And it's with the real numbers, which are just all the numbers, right? That's it. I mean, it's like so just really, really obvious, but they say it in a way where, in my opinion, it's not necessarily clear. So if we made a little number line and this was 0 and this was -1 and this was 1 and this was 2 and this was 3, and we came along and put a happy little point there, that point is the 1 to 1 value is 3. That's all it's talking about, and 3 is a real number. The point on a line right here can be put into a 1-to-1 correspondence with a real number, which is just, you know, the value. So 1 point equals 1 value. And that's true if we put another point over here on -1. That's 1 point, and that 1 point has 1 value, which is -1. So that's all that's talking about. So there you go. Okay, next idea to talk about is distance. So distance, or length, between any 2 points is the absolute value of the difference of the coordinates. So here we have a line. Okay, those are our 2 points, point A and point B, and those have a value. Here they're just calling the values A and B. They're keeping it pretty generic. But what they say is the distance between A and B, and see how they write that notation AB like that? That's talking about the distance. Is the absolute value by taking the difference. Remember, difference is that word right there, difference means subtraction. So you take A and you subtract B, and then you take the absolute value of it. Or you can go B minus A and take the absolute value. It doesn't matter. Either of them, you get the same answer. So let's go ahead and try this out. Okay. So example 1, finding the length of each segment. So BC, so when we see this, we know that we're going to find the distance between B and C. Okay, so BC is going to equal the absolute value of the difference of these two values. So B is 1 minus 3. And we're going to take the absolute value. 1 minus 3, 1's positive, 3 is negative. We take the difference of those two, we get 2. And which number is bigger, 1 or 3? 3 is bigger and 3 is negative, so our answer is going to be negative. So the answer is -2. Then we just end up taking the absolute value of -2, and we get 2. So the distance from B to C is 2. Okay? And that's how you'd show your work. So that's very, very important. You're going to do homework problems. You're going to have to show your work. And guess what? Your work should look like this. That is how your work should look. So you should be able to go back to your homework assignment, do a problem that's like this, talking about distance, and then refer back to these notes. And your problem should look exactly like this. If it doesn't, then you're not doing it right. You need to rewrite it, and it should look like this. Okay, notice how my lovely equal signs are all lined up nice. Okay, perfect. Let's do AC. Okay. I think I'm going to use blue. All right. So AC, we just take we're trying to find the difference here. We're going to take the difference of these two values. So the difference, remember, is the absolute value of the difference. So A is -2 minus C, which is 3. And AC is going to equal, we have to simplify this. So this is negative and this is negative, so we're going to add those values together. 2 plus 3 is 5, and keep the negative. -5 like that. And then we just take the absolute value, and we get absolute value -5. Remember, that's the distance. -5 is away from 0, which means it's just going to be a +5. And there you go. Now it is your turn, ladies and gentlemen. Okay, and I want you to practice, check it out, example 1. You're going to be working on finding the distance of xy and finding the difference of xz, and make sure that yours looks exactly like this and exactly like this, okay? So I want you to go ahead and pause your device, work those two problems out, and then press play, and we'll talk about them in just a little bit. All right, we're back. Let's see how you did. Okay, let's find the distance of xy. So remember the distance of xy is the absolute value first of 1 1/2 minus y, which would be 5. All right, so we have a nice little mixed number here. I'm going to go ahead and change both of these into fractions that have a common denominator. So I think what I'm going to do is I'm going to change this into an improper fraction first. The way you do that, remember, is you take this number, you multiply it by this one, and then add it to that one. So 2 times 1 is 2, plus 1 is 3. So 3, and then you just keep that denominator. 3 over 2 minus, and then I'm going to make this into 5 over 1, and I want a common denominator of 2, so I'm going to multiply the top and the bottom by 2, and I end up getting 10 over 2. All right, now I have my common denominator. And so I'm just going to subtract the numbers on top. So 3 minus 10, 3 is positive, 10 is negative. So I take the difference of those numbers, which is 7. And what number's bigger, 3 or 10? 10's bigger, 10's negative, so it's going to be a negative 7 over 2. So there you have it. And then I just need to take the absolute value of that, which ends up being 7 over 2. And then I think I'm going to convert this back into a mixed number. So to do that, you just go ahead and figure out how many times does 2 go into 7. And it goes in 3 times. 2 times 3 is 6, and so there's 1 left over. And you keep that 2 on the bottom. So there you go. That's how you solve that problem. So your answer should look like this, right here. If it doesn't, then I want you to erase what you have and write down what I have. Okay, so you should be writing in pencil. Make sure you have a pencil when you're doing these notes. All right. Let's move on to B. So B. Okay, here we go. XC, the distance between XC. So I'm going to take x is 1 1/2, so it's the absolute value of 1 1/2 minus z, which is a negative 3. Absolute value. Perfect. Okay, so here we have fractions and non-fractions again, so let's go ahead and convert this into an improper fraction and then get a common denominator. So once again, to do that, you take this number, multiply it by that, add it to that. So 2 times 1 is 2, plus 1 is 3. So we're going to end up with 3 over 2. Minus a negative is going to end up being positive. And then this is going to be 3 over 1. I want it to have a denominator of 2. So I'm going to multiply the bottom and the 2 both by 2 because 2 divided by 2 is 1, and you can multiply any number by 1. And you get the same number, just in a different form. So 3 times 2 is 6 over 1 times 2 is 2. Okay. Then we just simplify this. I get xc equals the absolute value of 3 plus 6, which is 9 over 2. Then I'm going to take the absolute value of 9 over 2, which is talking about the distance of how far 9 over 2 is away from 0, and it's just 9 over 2. Distance is always positive. And then I want to go ahead and convert this improper fraction back into a mixed number. Remember to do that. I want to see how many times does 2 go into 9. It goes in 4 times, because 4 times 2 is 8, and then there's 1 left over. So you keep that number on the bottom. So XC is 4 1/2. So if you got that right, and your problem and your work and your equal sign, they all line up and they look perfect and everything looks good, then great job. All right, good work. That's it for example 1. I'm going to Stop the video and then go ahead and watch example 2 when you're ready.